Welcome to the session on differentiation, sketching gradient functions. The objectives for this session are to sketch the gradient of a given function. It is possible to use the features of a function to sketch its corresponding gradient function. If y equals f of x has a maximum or minimum, y equals f dash of x cuts the x-axis at the corresponding value of x. Let's take a look at an example. Consider f of x equals x squared. Here's a sketch. Now f dash of x equals 2x and f double dash of x equals 2. We also know that f of x has a stationary point when f dash of x equals 0. Therefore, f of x has a stationary point at x equals 0. Here. Now, since f double dash of 0 is greater than 0, f of x has a local minimum at x equals 0, as shown here. Now f dash of x can be sketched here. It's of course equal to 2x. And notice that f dash of x cuts the x-axis at the corresponding value of x, where f of x has a minimum, in other words at 0, here as shown. Now let's have a look at some key features of y equals f of x, which will allow us to sketch y equals f dash of x. Consider this example. Consider the graph of the function y equals f of x, as shown here. The derivative of this function can be sketched using this graph, and it will look something like this. How did we obtain this? Take a look at the graph y equals f of x. It has a local minimum as indicated, and therefore for the function y equals f dash of x, its graph will cut the x-axis at exactly this point. Also, y equals f of x has a point of inflection at the indicated point, and therefore the graph of y equals f dash of x will touch the x-axis at exactly this point. Here, in y equals f of x, we have a positive gradient. Therefore, the graph of y equals f dash of x is above the x-axis. And here, again, we have a positive gradient in y equals f of x. Therefore, the graph of y equals f dash of x is above the x-axis. And here, we have a negative gradient for y equals f of x. Therefore, the graph of y equals f dash of x is below the x-axis. Now let's take a look at another example. Consider the graph of the function y equals f of x as shown on your screen. The derivative of this function can be sketched using this graph, as shown towards the bottom of your screen. Let's examine how this graph was produced. So in the graph of y equals f of x, we have a negative gradient in the area indicated. Therefore, this area of the graph for y equals f dash of x is below the x-axis. Similarly here, again, in the graph of y equals f of x, we have a negative gradient, so again, in the graph of y equals f dash of x, the graph lies below the x-axis. Here we have a vertical asymptote in y equals f of x, and therefore we have a vertical asymptote in the same position for y equals f dash of x. And finally, we have a horizontal asymptote in y equals f of x, here as indicated, and therefore we have a horizontal asymptote in the same position for y equals f dash of x. Now let's consider another example. Consider this graph, y equals f of x. The derivative of this can be sketched using this graph, and it will look something like this. Let's examine how this graph was obtained. Notice here we have a positive gradient for y equals f of x. Therefore, the graph of y equals f dash of x is above the x-axis. Here we have a maximum turning point in y equals f of x, and therefore in f dash of x the graph cuts the x-axis. We have a negative gradient here in y equals f of x, and therefore where we have this negative gradient, the graph of f dash of x is below the x-axis. And here we have a positive gradient, and therefore the graph for y equals f dash of x is above the x-axis. This brings us to the end of this session. If you have understood its contents, you should be able to sketch the gradient of a given function. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.